Hey everyone, and welcome back to the Biochemistry YouTube channel. Today we're going to be talking about the hormonal regulation of metabolism. For this, I'm going to be using a diagram that I think is really helpful to visualize this process going through. Before we talk about anything, I think it might be smart to identify some terms here. We have some hormones on the left side of the screen, insulin and glucagon, that you may not have heard of before. Insulin is the fed state hormone, which means that it's produced anytime that you eat something and want to reduce your blood sugar. Glucagon is the fasting state hormone, which means that it is produced to increase blood glucose level if you haven't been eating. Now, let's think about the big picture and look into this as if it is a real-life scenario with someone with high blood glucose. If we have a high blood glucose, maybe we're a diabetic. If our glucose is high, we want to secrete insulin to drop our blood glucose level. This synonymously happens as GLUT2, an insulin transporter, is secreted out. It is for specifically pancreatic beta cells, which means that it is directly for the insulin to be transported. The combination of these first two steps leads to an increase of insulin-sensitive protein kinase 1, which is extremely important because it leads to an increase in our next step. Now, that links into protein phosphatase 1. Protein phosphatase 1, or PP1, is a ubiquitous enzyme that regulates carbohydrate metabolism. This leads to an increase in glycogen synthase and phosphorylase kinase enzymes, which essentially creates a lesser amount of the breakdown of glycogen stores. Remember, this is happening because we're trying to reduce our blood glucose level, not increase it. Now, on the right side, we see that the GLUT2 leads to an increase of glucose, right? So what do we do here? That underlies an increase of rates of glycolysis and a decrease in the rates of gluconeogenesis because we don't want to be making more sugar. We increase glycogen stores for future use. Now, let's talk about the opposite situation, in which we have a situation where someone would have low blood glucose. For low blood glucose, it's essentially the opposite of what we just talked about. Maybe you haven't eaten all day. For this, let's think back to our hormones. We're going to be using the fasting state hormone, glucagon, as an increase. We increase glucagon because it directly generates cyclic AMP. This activates a liver phosphorylase to convert glycogen to glucose in order to increase the blood glucose level. This also increases pKa, protein kinase A, which decreases glycogen synthesis. Once pKa is increased, it actually increases the activity of an enzyme called phosphorylase kinase. This phosphorylase kinase ends up increasing the amount of glycogen phosphorylase, which then increases the stimulation of glycogen breakdown, which is what we want to increase the blood glucose level in the body. On the other side, we see a decrease in pyruvate kinase. But why? Because we don't want any more glycolysis. We don't want to break down any more glucose than we have to. That would in turn decrease our blood glucose level. Then, we also see that fructose bisphosphatase 2 and phosphofructokinase 2 are inversely regulated in this process as well when pKa increases. If you're unfamiliar with these terms, I'd suggest that you watch our next video on glycolysis regulations. With this, after that step, fructose 2,6-bisphosphatase is also decreased, therefore decreasing the activity of phosphofructokinase 1, which is the third step in glycolysis. Again, this is done to make sure that glycolysis is not happening because we do not want to lower this blood glucose any more than we already have. And with that, now you should know exactly how blood glucose is regulated within the body. I hope you enjoyed this video. In the next video, I'll talk about how phosphofructokinase is regulated in glycolysis. Have a great weekend, and good luck on exam 3.